Hello everyone, this is the another video of this challenge, and right now I am learning the sorting algorithms. I have explained the selection sort and bubble sort in my previous video. You can also check them in the I button above and also in the description. So now in this video I am going to explain the insertion sort. So firstly I will discuss that what is the insertion sort, what is the core idea behind it, how it works, and then the implementation part of this algorithm, and then what is the analysis of the time complexity, and also the different properties which are of the sorting algorithm. So firstly, get into the let's get into the insertion sort. So what is insertion sort? Firstly, it is a kind of sorting algorithm in which the sorted portion is maintained at the left part of the array. Okay, and every time whenever the new element comes, it just checks the elements, that what elements can be shifted towards right. Okay, or what the shifting can be made so that that element, the new key, can be inserted at the correct position. So at every time, at every step, whenever the new element comes, the sorted portion increased by one element because the new element gets inserted into its correct position. And after some number of steps are performed, the entire array gets sorted. So every time what it happens, that the sorted portion grows by one element at a time. So that's what I have mentioned here, that the insertion sort, it is a kind of sorting algorithm which builds a sorted part of the array at the left part, and that increases by one element at a time by inserting each new element into its correct position. So every time the new element comes, it sees for that where it can be inserted at the correct position, and every time this sorted portion gets increased, and then it takes up the entire size of the array so that the entire array can get sorted. So this is all about the core idea of the insertion sort. Now let's get into the example to have the better understanding of this. So this is the example I have taken here. The elements are 5, 2, 4, 6, 1. We have to sort this particular array using insertion sort. Now initially this is the sorted portion. Okay, I am considering that initially I am having this sorted portion, and this one element is in itself a sorted portion. Okay. Now what we will do, we will just start from the first index and go till the last index in order to insert these elements at this sorted portion. So just what we have discussed in the core idea, that we are having a sorted portion already, and now we have to insert the elements one by one in the sorted portion at their correct position. So just uh, think that we are having this sorted portion already at the 0th index, this 5 already sorted in itself. Now new element will be coming from starting from one index. So when this 2 will come, it will just check for this element, that where I can be inserted. It will check that yes, 5 is greater than me. So what will happen, this 2 will be going before this 5. Okay, so for that, now if 2 has to come before 5, so firstly 5 has to shift towards right, then only 2 can come here. Okay, so this 5 is greater, so then this 5 will be shifted towards right, and then 2 can come here. So that's what written here, that firstly we have to insert this 2. Okay, so currently we are at the index 1. So now I am just giving a basic idea with this example, that how the algorithm is going to work. Then we will see the implementation part, that what the implementation or the logic we will be using to write the code. So this is the basically the logic is the important part, that how the things are working here. So firstly we are at the one index right now, and we have to insert this 2 at its correct position in this sorted portion. Now 5, we have seen that 5 is greater than this 2. So therefore what will happen, this 5 has to go before 5. Sorry, this 2 has to go before 5. So 5 has to shift towards right, and then only 2 can come here. So 5 will be shifted towards right, and then how the array will look like? Array will look something like this, that 5 will be shifted here. Okay, now we need not to worry about the this key which we have to insert. That we will save inside a separate variable, so that whatever the alterations are made, whatever the shifting is made, that the key is already saved inside a variable. So that key is already saved inside this key variable. Okay, so this 5 will be shifted towards right. So the array will look something like this, that 5 is at one index, and this is already 5 in itself. Now as we have no any elements in order to check that where this shifting can be done, so therefore all elements has been finished. So we will just take this key 2 and insert at this position, and the final array will look like this after shifting. Okay, this 2 is here and 5 is here. So now we can say that this is the sorted portion. In the first step, what happened, this one element is the sorted portion in first step. Now before going to the second step, we are already having two elements as the sorted portion. So now we came from one index to the second index. Now we will be inserting 4 at its correct position in the sorted portion. So this is the sorted portion in step 2. These two elements are sorted. Now we will take one by one element and check that where this 4 can be inserted. So is this 5 greater than 4? Yes, this is greater. So therefore the 4 cannot come after 5. It has to come before 5. Okay, so for that, we will have to firstly shift this 5 towards right, then only 4 can come before. So in that case, this 5 will be shifted towards right at this place. Okay, 5 will be shifted here, and now this position is empty now. Now already the 5 is there, we can say in that way. So 5 is already shifted towards right. Now one element is also there, we will also have to check with that, that is this 2 less than or greater than. So 2 is less than, so we need not to worry about that. This 4 will be coming after 2, so we need not to shift that 2. So therefore now we have this position left, this position to insert the 4, where we have shifted towards this 5 from where we have shifted. So now this 4 key will be coming at this place. So the array will look something like this: 2 4 5 6 1. Now this entire 3 elements are sorted. So when we are moving towards the third step, we can see here that these 3 elements are sorted, as we are coming in the flow from different from the multiple steps. So in step 3, we have seen that these 3 elements are sorted. Now we will be moving this I towards the next index. Now 6 will be inserted at its correct position. So this is already a sorted portion. And now when 6 will come, we will firstly check with this 5. See, now 6, when it checked this 5, it sees that yes, 5 is lesser than this and 6 is greater. Because this is already a sorted portion, these elements are in the ascending order, and this element is greater than the last element, therefore no any shifting has to be done. This 6 is already at its correct position, so therefore no any shifting will be done. And just normally we will move this I towards the next index in order to insert 4 at its correct position. Okay, now again the same process will be followed. 6 is greater than this 1, so therefore this 6 has to be shifted towards right. Okay, so 6 will be shifted towards right. Then 5 will be compared. 5 is also greater. 5 also has to shift towards right. Then 4 will be compared. 4 will also shift towards right. 2 will be compared. 2 also shift towards right. And when this place is just empty, we can say, so that then that 1 can be inserted at this position, and therefore the array gets sorted at this fourth step, because all the elements has been visited in order to insert at the correct position in the sorted array. So this is the simple simulation of this, that firstly 6 will be shifted towards right. Okay, so 6 will come here, that I have shown with different color. Then 5 will be compared, so 5 will be coming at this, shifted towards right, so 5 will come here. Then 4 will be shifted towards right, so 4 will come here. Then 2 will be shifted towards right, so 2 will come here, and therefore this position remains, and this position becomes eligible in order to take the 1 can be inserted at this position. So therefore after shifting, this 1 comes at this position. Okay, and therefore we can say this entire array is sorted. So this is the whole logic of this, that how the shifting works, how the elements are compared with the key, that where the key has to be inserted, and based on that, if the element is greater than the key, then first that element has to be shifted towards right, then only we can make the place for that key to be inserted. Okay, now let's talk about the like implementation part, how we can code this. See, what happening is, we are taking this index I from the index 1. Okay, we are keeping this index I, or we can say this I pointer at the index 1, and initially we are saying that this particular 1 element is already sorted in first case. So in step 1 element is already sorted. I will be starting from index this index 1. So now we in order to check for the previous elements, then what elements has to be shifted, we will have to take one another pointer. We can call it that pointer as j, and that pointer will be starting from I minus 1 index. I am taking this I at 1 index now, so I will have to take another pointer j, which will be pointing towards I minus 1, that is a 0th index, and then we will start checking that this element is greater than this or not. If it is greater, we will shift again. Okay, and in order to go to the previous element, we will again take that j back, that pointer back. So initially what will happen, j will be coming here. Okay, and for this element, we will be checking that this element is greater than the key or not. So if it is greater, we will shift this, and again we will move this j to the back. And now when j is moved back, every time before comparing the element that it is greater than the key or not, firstly we also have to check that it is having at the valid index or not. So it can be the case, like in this case, the j is now at the -1 index, and that is an invalid index. So firstly we have to check that the index is valid or not. Then only we can check that for the element. Obviously, if the index is valid, then only we can check for the element. Okay, so if the index is going out of bound, or the invalid index, we can say, so at that point we will not be checking anything, and therefore it is also a kind of representation that we have now visited for all the elements before this particular index for which we have to insert. Okay, for the key which we have to insert. Before this, I have visited all the elements. So that's how it works in this case. Now j moved here, so the this particular thing will stop, and now we will move to the next iteration, like it's for the next index. So I will then move to the next index. Now I will move to the end, this next index. So j will again come at the I minus 1 index. Now it will check for 5. So 5 is greater, 5 will be shifted towards right, and therefore uh, then this j will be again moved back. Okay, then it will be checking for 2. Now 2 is already lesser, so no problem. In that case 2 is already lesser, so condition will, in this case the condition will be false. Okay, so it means that we have already checked. So now what will happen, j is already at this index. When we will, before moving to the next particular element to be inserted, firstly we have to insert this. So in order to insert this, whatever the j is pointing at the index, that j plus 1 will be the index where this I will be, this particular element will be inserted, this key will be inserted. How? See, I is pointing at this 2 index. Okay, now we have firstly checked for 5. So 5 is greater, therefore 5 will be shifted towards right. In this way, 5 came at this position. Okay, and now this position is a kind of empty where the new element can get inserted. But before that, we also has already moved this j back in order to check 2. Now 2 is lesser, so we need not to shift it. So therefore, from this we came to the conclusion that this key which has to be inserted, it is lesser than 5 and it is greater than 4, therefore it will be coming in the middle of this. So already we have shifted 5, and whatever the position at j plus 1, that 4 will be coming at that position. Okay, so that's what the intuition behind this. So 4 will be coming at this particular position. Okay, so this is the position it came. Now again, let's check with another example. Again I is moved at this position. Okay, now in this case it is already at this, j will be coming at this I minus 1 index. So this is already a element which is lesser than this. So I've already explained this, because this portion is already sorted, and the next element which has to come, it is already greater than this j, the just last element. So it is already greater there, thereby it is already at the correct position. So therefore we need not to shift any elements. We can directly go to the another index. Okay, in order to check for the elements, we can go directly. So because this j plus j is just here itself, so when moving to the next element, we can just say it like that, that whatever the j plus 1 index is there, we will be inserting that element at that position itself. Okay, and then we will be moving to the next index. Now I will move to the next index, then I will move to the next index from this 3 index to 4 index. Now in this case, this particular element is firstly compared with this. So j is firstly pointing at this index. Okay, so 6 is already greater than this one, so therefore 6 has to be shifted towards right. So in this way, in this case, this 6 will go, this 6 will come here. Okay, 6 has moved here. Now this is the portion where this element can come, but before that we checked with 5. So 5 is also greater, therefore 5 has to also shift here. Okay, so 5 shifted here. Now again we will be moving this j firstly moved at this index, then j will be moved at this index. Now 4 is again greater, so 4 also be shifted. Then again this j is moved at the previous index, so again 2 is greater, so 2 will also be shifted, and thereby this j again moves at the back. Now already this we have now again when we will be checking the condition, j is now at the invalid index, that is the -1 index. So in that case we will just stop then and there, because we have already checked the elements, and therefore at the end whatever the j plus 1 index is there, this is the index -1, okay, plus 1, that is 0. So that is the 0th index. At this index that key will be inserted now. Okay, so that's what the correct uh, position for that element, for this one to be inserted. So now this one will be shifted at this place. Okay, that's how the logic is working. That's how the I and j are working. That we will also understand more when we write the code. So let's get into the code part, and let's understand more about it. Firstly I will write the code and then again dry run on this example. So firstly I will be taking the size of this vector nums. So nums dot size. And, after this what I have to do is, see here in the step 1 I have started this I from index 1, because already I am considering that this part is already sorted, and it is already sorted. Okay, in itself. So this I outer loop will be moving from index I to sorry, this index 1 to index last. Okay, and for every firstly let me write this loop for int I equal to 0, sorry, int I equal to 1, it will be started from 1 because index 0 element is already sorted in itself, less than n and I plus plus. Now inside this loop, what we have to do is, firstly, whatever the element we are having, this I is at currently at 1, so this 2, we have to insert this 2 at its correct position. So before starting any operations or any shifting, firstly we have to save this inside a key. Okay, so I will just take a key variable and save this nums of I inside that key, so that whatever the shifting or whatever the alterations I am doing on the elements, it cannot change this. Okay, so I have just placed inside a key, and now what I did was, I have taken a j pointer in order to check for these elements, and where that j pointer is pointing at I minus 1 index. So whatever the j pointer is there, it will be pointing at I minus 1 index. So therefore the j is currently here. Now j is currently here, and now what I will do, I will run a loop that will be a while loop. Okay, so in that while loop, what will be the conditions? That's the most important thing. This while loop will check for the elements, that if they are greater or not. But before checking that, I will also have to make sure that this j index is at the correct index or not. So firstly I will have to make a check if this j is greater than equal to 0. Okay, and if this is the valid index, then only I will be checking that this nums of j, whatever the element is there, if it is greater or not. So I will put a condition for nums of j, that if it is greater than the key, I have to insert the key. Okay, so if this is greater than the key, this is the 5, this is greater than the key. So now, can this 2 be inserted or can be placed at this position itself? No, it has to go before this 5 because this is greater. Therefore, for that purpose, this 5 has to shift towards right. And in order to shift towards right, this nums of j will be going at nums of j plus 1. Okay, so this nums of j will be going at nums of j plus 1. Okay, this we have done. Okay, now this 5 has already shifted here. In this way, 5 has already shifted here. After shifting, it is looking like this. And now what we have to do, we also have to check for the previous elements as well, and in order to do that, we will be decrementing this j. Simple. So now this j will be moved at the back here in order to check for the more elements. But after decrementing and moving at this condition again, we will again be checking that this j is greater than 0 or not. It means it is a valid index or not. And we checked that this index is -1 and -1 greater than equal to 0. This condition is false. Therefore, I'm not going to check any element because obviously the index is invalid. So what elements I will check then? So firstly, this is the important condition, that firstly check that the valid index or not. And if it is valid, then move to the elements to check. Okay, so now the condition is invalid, then I will be coming out of the loop. And when I come out of the loop, what I have to do now, that's the most important point here. After coming out of the loop, when all the elements has been visited, now what key I has to insert? This key I has to insert. And at what position? J is at right now here, and this is the position which I have made the place for the key to be inserted by shifting right shifting this element. So this is the place the new element will be inserted. So that's the place what j plus 1 index. Okay, so that will be like nums of j plus 1, and here that key will be coming. So that's the key which will be inserted. Now again, let's move to the another here example. Now when this particular loop will be completed and this key is inserted, now we will move to the next index, that is I equal to 2 index. So this is the I equal to 2 index. Now what happened here? This key is I have already saved. This 4 is already saved inside the key. Now, okay, so this is the key which I have saved inside this 4. Now I have taken this j at I minus 1. So this j will be coming at this I minus 1. It will firstly check for this is the valid, is this a valid index? So yes, this is a valid index. Now check for the element. So is this element greater than this? Yes, this is greater. So therefore, in order to keep this element before this, I have to shift this towards right. So this will be going at nums of j plus 1. It means at this position, 5 will be coming here. And after this, I will also have to check for the previous element as well. So for that, the j will be moving towards back. Okay, for the left. And it will check for 2. Is the 2 greater than 4? No, it is not greater, it is lesser. So therefore, I need not to shift this element towards right, because the 4 can come after that. Okay, so therefore this again for this particular condition, this condition goes false and this goes false, so therefore we come at this line. Now J was at this index and therefore this key has to be inserted. So obviously we had made the place for this 4 in order to be placed here by shifting this 5 right. So this place is already there for to insert this key, and J is here right now. So J plus 1 will be the index where 4 will be inserted. So J plus 1 is the index where this key will be coming. So that's again the same thing. So that's how the code is working. Let me just take an input here. What is the input? 25461. This is the size of array, and 25461. Okay, this is the input, and let me now just run this code. It will be giving the sorted array, that is 1 2 4 5 6. Okay, so this is the output of this 1 2 4 5 6. This is the sorted array, the result of this output. So now let's just take this code and just to see for it. We have I have already just explained it with a diagram for these 2 steps. Let's move for the next steps as well. So this is the code which I have written, and now we have checked for this. Okay, so 4 is now inserted at this position. 4 is now inserted at this position. Okay, so now let's move to the step 3, and in this step 3 again this I is moved at the next position from here. Okay, I at 3 index. Now this element has to move. Now we can see here that this j will come at this I minus 1 index. Again it will check for this. Firstly it will check for the valid index. So index is valid, then it will check for the element. So this element is lesser than the key, so therefore this condition goes false, and at the end this j plus 1 will be the index where this element will come. So that's the no change in this. Okay, so this is the example, and this is the step for this. And again when we move this index to the next index, that is at 4, so now again this key will be saved inside this, that 1 will be saved inside the key. Okay, and after this j will be coming here at the last index, I minus 1 index. So this element will be again, now firstly the valid index is there, so yes, this element is greater than the key, so yes. After this key will be going at the j plus 1 index. Okay, so then 6 will be coming here as it is simulated here, and then this j will be decremented, so j will be decremented. Now this 5 will be shifted towards right, so 5 will be shifted towards right, and then again this j will be decremented. Again now 4 is again greater, so this 4 will be shifted towards right in this way. Okay, so again this j will be decremented. Now j will be decremented at this 2 element. Now again the valid index is there and also the element is greater, so again this 2 will be shifted towards right as it happened in this. Now again j will be decremented back. Now the index is not valid, so condition will go false, and in that case we come out in this line. So when this line will be executed, again this j is at minus 1 index. When plus 1 will be done, so that will be going at 0th index, and this key will be inserted here. So that's what the key intuition behind this, that how the key is checking the elements one by one, that where it will be inserted, what is the correct position by checking the element. If the element is greater, it has to shift towards right, and then the position will be made, then the place will be made to insert that element. Okay, so this while loop runs until the index is valid, and also whatever the elements we are checking for, if that elements are coming greater than the key, so therefore till that time we have to shift these elements towards right. And the moment any of the condition goes false, like index is invalid, okay, means j is going at the minus 1 index, or any element has found to be lesser than the key, so therefore till that moment the loop will run, otherwise we will just come out of the loop. And whatever the j is pointing last, that j plus 1 will be the index where that key will be inserted, and that is the correct position that we have just seen with the different examples, and also the intuition that how it is working. So this is what about the code. And now let me also tell you that why is it is the only thing that how it is working. So because at every step we are seeing that we can analyze that whatever the steps are performed, like in step 1, if we can see in step 1 this one element is already sorted. Okay, in step 1 this one element is already sorted in itself, this 5. Now we have to insert for next element to be inserted in the sorted portion. Now if we see in the second step, 2 elements were already sorted. Okay, if we see in the third step, 3 elements were already sorted. If we see in the 4 elements, this 4 elements were already sorted. So this is how, if we see that in every step, whatever the elements are coming to be inserted inside the sorted portion, at every step, if we talk about the I steps, so I at the ith step, the I number of elements were already sorted in the left part. So because at every step the left portion of the array is always sorted, we insert the next element in its correct position by shifting the larger elements to the right. Okay, so that's why it is working. At every step, what we are doing, after every step, the I elements are always sorted. Okay, so that's why we are performing these number of steps. Whenever the new element is coming, it is just checking for its correct position and getting inserted to it. And every time this sorted portion grows by one element at every at one at a time. Okay, we can say in that way. So that's why the left portion of the array is always sorted, and every time when we insert the next element to its correct position, it just shifts the larger element to the right. So that's why this, after I steps, the first I elements are always sorted. So for the time complexity, we see that in the worst case scenario, what can be the worst case scenario? That the entire array is sorted, but it is in the reverse order. It means now whatever the element we will be inserting, whatever the elements we will start taking from the index 1 till the end, one by one element we will have to shift the maximum number of elements from the previous sorted portion. Okay, so if we see this 4, if we have to this insert this inside the sorted portion, firstly we will have to make this one shift. For this 3 has to be inserted, we will have to perform the two shifts, because after this what will happen, see, when we will be inserting this 4 here in the correct position, so it will look in the first step, how it will look like 4 5, then 3, then 2, then 1. So here we have seen that first element has to be inserted, so one shift has to be done. Now when 3 will be coming here, so firstly 5 will be shifted, then 4 will be shifted. So how it will look like, it will be like firstly 3 has to come here, so 5 will be shifted, 4 will be shifted, so it will look like 3 4 5, then 2, then 1. So here two shifts were made. Now when 2 has to come, 3 shift has to be made, 5 will be shifted, 2 will be 4 will be shifted, 2 will be shifted. It will look like 2 3 4 5 1. Now when 1 has to come, 4 shifts will be made. It will be like 1 2 3 4 5. So therefore in the reverse sorted array, when every element, when it comes, there we have to perform the maximum number of shifts, because the array is sorted in the reverse order. Okay, so here as the one shift is required, two shifts are required, three shifts are required, four shifts are required. Okay, so for the first, the one shift is required, then two, then three, and likewise if we moved at the n minus one step, okay, five elements are there, four steps are required. So for the first step, one shift, second step, two shift, three shift, and three step, sorry, at the third step, three shifts, and then when you move at the n minus one step, then n minus shifts are required. Okay, likewise there can be the different inputs. So in that case, the summation comes to n into n minus 1 by 2, a kind of formula, that is n square by 2 minus n by 2. So that's like time complexity goes to big O of n square. Now it can also be going towards the best case for the, if the array is already sorted. So just think that if array is already sorted, then what will happen? Just let me take this input 1 2 3 4 5. The array is already sorted. Now what will happen here? When I is moving, I is at this one index, okay, this 2, at this 2. So for this 2, it will check for the elements. 1 is already lesser, so I is equal to 1. This key will be storing this element. In this key, what will be coming? This key will be storing this 2. Okay, now j will be pointing towards this 1. Now the condition is valid for this, the index is valid. Okay, now when the element is checked, it is greater than the key, no, so the condition goes false. Here the one comparison is made. Okay, now because this condition goes false, so nums of j, this element will be placed at its position itself. Next index will be coming. Now I will be pointing towards 3. It will check for the, now the key is 3. Okay, now the key is 3. J is pointing towards 2. Now the condition is valid for index, but 2 is lesser than this 3, so thereby the condition goes false. Condition goes false, 3 will be going at this place itself. Again one more comparison made here. Likewise, when all the elements from this I index, from this I equal to 1 index till the end index, for every index, because this array is already sorted, so whenever you will come inside this while loop, you will make one comparison only and for that one comparison, that condition will go false. Like for 2, it will check for 1, condition goes false. For 3, it will check for 2, condition goes false. 4, it will check for 3, condition goes false. 5, it will check for 4, condition goes false. So every time, for every element, when you are inserting that, trying to insert it, when you are checking this condition, only one comparison is made. And therefore we can see here that this outer loop is running for 1 to n minus 1, that is for n minus 1 times, and every time only one comparison is made and this condition goes false. Therefore for n minus 1 times, n minus 1 comparisons will be made. So here the best case will be that each element compares only once. Okay, each element only compares once, as we have seen there, only one comparison is made. So total of n minus 1 comparisons will be made for the n minus 1 times. Okay, so thereby the time complexity goes to big O of n, and this makes the insertion sort adaptive. We can see the best case. And the average case is simple, that if the, like in the average case, half shifts will be made, so in that case it will still big O of n square for the half shifts. Okay, now let's talk about the stability. So stability means, as we have already seen, that if any two, like for the equal elements, if their positions are altered in the previous two sorting algorithms as well. So in the stability in the insertion sort, we are taking each and every element and we are comparing it with the previous elements in the sorted portion, that what are the shifts has to be made. So if the element is greater, then only we are shifting the elements. Okay, otherwise we are not shifting any elements. Like if there are any equal elements, we are not making any shifts for those. So those relative order of those equal elements will not be altered, it will not be changed. Only when the element becomes greater, when it is encountered that it is greater than the key, then only it will be shifted to make the place for the insertion of the new key. Otherwise, if the equal elements are there, no any shifting will be done in that case, so their order remains unchanged. So that's why we can say that this insertion sort is stable. Okay, so this is a kind of property of it. Okay, so this is all about the insertion sort. We have seen what is insertion sort, we have seen the example, implementation of this algorithm along with the dry run on this example, okay, in detail. That's all for this video. We'll meet with the another sorting algorithms like merge sort and the quick sort in the another video. Thank you.